Good morning, students. In this class, we are going to discuss about the next concept in the p block elements, that is chemical properties of 14th group elements or carbon family, that we will discuss. Before going to this one, first we will see the oxidation state. Oxidation states of 14th group elements. Now, what are the elements of the 14th group? Already we know that the elements in the 14th group are carbon, silicon, germanium, tin, and the last element is lead. These are the elements which belongs to the 14th group. Those are carbon, silicon, germanium, tin, and the last one is lead. Now, if you see the general, here I am writing general valence shell electronic configuration of 14th group elements, that already we have discussed in the last video. General valence shell electronic configuration of 14th group elements is ns2np2. ns2np2. This is the general valence shell electronic configuration of which group elements? 14th group elements. Now here, how many valence electrons are there? 4 valence electrons are there. Therefore here all these elements carbon, silicon, germanium, tin, lead can shows the +4 oxidation state. If all the 4 electrons are involved in the bonding, then what will be the oxidation state? +4 oxidation state will be the shown by all the elements in the 14th group elements. And the new thing is, this carbon can also shows the -4 oxidation state. Means this carbon can shows both +4 oxidation state and also the -4 oxidation state. Means it has 2 oxidation states, whereas this silicon shows only +4 oxidation state. And these 3, germanium, tin, lead, this can also shows the +2 oxidation state. +2 oxidation state. Here, that is only I am writing carbon shows both +4 and -4 oxidation state, and silicon shows only +4 oxidation state, whereas germanium, tin, and lead shows both +4 and +2 oxidation state. Now here just check, this +2 oxidation state of germanium, tin, and lead is because of inert pair effect. Inert pair effect. Already we know the definition that we have discussed in the last class also. Then also I will tell once. Now what is meant by inert pair effect is, here what is the general valence shell electronic configuration? General valence shell electronic configuration of 14th group element. What is this one? ns2np2, correct? Now here, if only p electrons are involved in the bonding, here bonding is because of only p orbitals, whereas these s electrons or s orbital electrons are not involved in the bonding. Means here wrong, means not involved in the bonding. Because here s electrons are paired and they are not involved in the bonding. Therefore this effect is called as what? Inert pair effect. Because of only p electrons or the p orbitals are involved in the bonding. In the p orbital, how many electrons are there? 2 electrons. Means it can lose the 2 electrons or it can share the 2 electrons to form the bond. Therefore the oxidation state is +2 only. Here this is not involved in the bonding, therefore it is not considered in the oxidation state. Therefore when only p orbitals or only p electrons are involved in the bonding and the s electrons which are not involved in the bonding, such type of effect is called as what? Inert pair effect. Inert pair effect. Because of this inert pair effect, these germanium, tin, lead shows +2 oxidation state also. And what is the order of stability, sir, for the +2 oxidation state? Stability order of +2 oxidation state is stability order for which oxidation state? +2 oxidation state is, I will write here. Now germanium, which is present in the +2 oxidation state, is less stable than the tin, which is present in the +2 oxidation state, and also these both are less stable than the lead. Means the compounds of lead, where the lead is +2 oxidation state, is more stable than the compounds of tin and germanium, where tin and germanium oxidation state is +2. Means here the compounds of lead which is present in the +2 oxidation state is more stable than the compounds of tin and germanium when they are present in the +2 oxidation state. This is the stability order. Right. Now we will go for the reactions, that is chemical properties. Now one by one we will discuss. First here, one by one, first I will discuss with the reaction of 14th group elements with air. Means how the 14th group elements will react with the air, that we are discussing here. Now just check here, I am writing reaction. M means metal, right, or 14th group element. Just think that, don't think that it is a metal, sometimes non-metal is also there, right? Here M means what? 14th group element. 14th group element, right? M means when it is reacted with the air, that is O2. When this 14th group elements reacted with the oxygen O2, there is the two possibilities of formation of compounds. Means when these 14th group elements react with the oxygen, two compounds are formed. One may be monoxide, that corresponding monoxide. One oxygen means monoxide, and also it may form the dioxide, monoxide as well as dioxide. Here this element, right, a 14th group element and only one oxygen, therefore it is called, only one oxygen means it is monoxide. Here this 14th group element and it is having how many oxygen? 2, therefore it is called dioxide. Dioxide means when this 14th group elements reacts with the oxygen, it can form the two compounds. One is monoxide, another one is dioxide. Monoxide as well as dioxide. Now if this is M means carbon, then it may form carbon dioxide and carbon monoxide. Correct? Here monoxide, dioxide. If M is carbon means carbon dioxide, carbon monoxide. Now if M is silicon, then it can form silicon dioxide. Here silicon monoxide is not formed. Why? We will see. Now here next, if M is germanium, right, next 14th group element germanium, means it can form germanium dioxide and germanium monoxide. If it is tin dioxide, tin monoxide, right? If it is lead dioxide, lead monoxide. Clear? Here monoxides I wrote here, carbon monoxide, germanium monoxide, tin monoxide, lead monoxide. Here I wrote dioxide, carbon dioxide, silicon dioxide, germanium dioxide, tin dioxide, lead dioxide. Now here we will see the general characteristic properties of these dioxides and monoxides. Now here these three, carbon, silicon and germanium, here these three, here I will write carbon dioxide, silicon dioxide and germanium dioxide. These can react with the bases. These can easily react with the bases. Means what is the nature of this carbon dioxide, silicon dioxide, germanium dioxide? I told opposite you have to take. Means this nature is acidic in nature. Means carbon dioxide, silicon dioxide and germanium dioxide are acidic in nature because they can react with the bases. Means here these three are, here I will write acidic in nature or acidic oxides, whereas these two here. Now what are those? Tin dioxide and lead dioxide. These can easily react with the acids. These can react with the acids. These can also react with the bases. Means the substances which has the capacity to react with the acids as well as bases, or the substances which can has the capacity to behave as acids as well as bases. What is the nature? Amphoteric nature. These all things we have discussed already. amphoteric nature, means when these reacts with acid, these act as the bases. When these reacts with the bases, these act as the acids, means these can act as both acids as well as bases. Therefore it is called amphoteric nature. Means here these tin dioxide and lead dioxides are amphoteric oxides. These points are important for NEET. Amphoteric oxides. Now, whereas if you check the nature of carbon monoxide, here carbon monoxide, it is neutral. It is not acid, it is not base. Whereas carbon dioxide is acid, whereas carbon monoxide is neutral oxide. Neutral oxide. Here similarly, this germanium oxide is acidic in nature. Acidic. And these two are amphoteric. Amphoteric. This is the general characteristic properties of the 14th group elements, monoxides and dioxides. Dioxides and monoxides. Here I wrote. Correct? Next we will go for the second. That is reaction with water. Before that one I told here silicon monoxide is not possible. Right, here it is not formed because the silicon monoxide is formed only at the important point is high temperature. Means the silicon monoxide is formed only at high temperature. At normal temperature it is not formed. Therefore I have not wrote this one here. Correct? Now just remember this one. Now next we will go for the reaction with water. Reaction of 14th group with water. For this one I will take second paper. Next I will write here. Second one is with black pen I will write the headings. Reaction of 14th group elements with water. Here I wrote full heading. Reaction of 14th group elements with water. That is H2O. Now we will see how they will react. Now here. Now just check. Here first I want to take one rough paper. Now just check. Here this is the beaker which is filled with the water. In this one first I am adding carbon. In this beaker I am adding carbon. Now I am observing what is happening here. Nothing is happening. Means carbon is not reacted with the water. Carbon is not reacted with the water. Next I am adding here in the same beaker, in the water only I am adding silicon. Now I am checking, is there any reaction between the silicon and water? Silicon and water. Again there is no reaction. Nothing is happening. Means silicon is not reacting with the water. Means silicon is also unreacted with the water. Next I am adding germanium in the water. Germanium. Here it is. Germanium in water. Again I am checking, is there germanium and water reaction is there or not? That is germanium is reacting with water or not? That is I am checking. Again germanium is also not reacting with the water. Germanium is also not reacting with the water. Similarly last I am adding lead, that is Pb in the water. Again this Pb is also not reacting with the water. Means nothing. There is no reaction. There is no change. Means nothing is happening between the lead and water. Means lead is also not reacting with the water. Lead is also not reacting with the water. Now what I am doing is I am taking another beaker which is also filled with the water. In this one I am adding the tin. Here SN. Right? Here I am checking, is there any reaction between tin and water or not? Yes, there is a reaction. And it will releasing slowly. When you add the tin in the water, if you observe, it is releasing one gas. And that gas is hydrogen gas, H2 gas. Means here I will write the reaction when tin reacts with water. Here when tin reacts with water, it will form corresponding oxide, tin dioxide, and releases the dihydrogen as gas. Right? when tin reacts with the water, it will form corresponding oxide and it will releases the hydrogen gas. Means carbon is not reacting with water, silicon is not reacting with water, germanium is not reacting water, lead is also not reacting with water. Only the tin is reacting with water, because when it is present in the +2 oxidation state, when this tin is present in the +2 oxidation state, it is a strong reducing agent. It acts as a strong reducing agent. Therefore, it will react with the water. Now, question is, why tin react with the water? Because when +2 oxidation state is there for the tin, it is act as a strong reducing agent. Therefore, it will react with the water. That is enough. Now, we will see the reactions. Only one reaction I have to write, correct? Now, that is tin only reacts with the water. For balancing, I am taking 2 moles to form corresponding dioxide, that is tin dioxide, and releases the gas. Which gas is released? Dihydrogen gas is released. Here it is gas, right? When this tin is added into the water, it will form corresponding oxide. Here it is corresponding dioxide, right? Tin dioxide, and releases the gas. Which gas is released here? Dihydrogen gas. Dihydrogen gas. Why only tin is reacting with the water? Because for this one I will write, because tin, when it is present in the +2 oxidation state, it is a strong reducing agent. Strong reducing agent. Therefore, the tin only react with the water, whereas carbon, silicon, germanium and lead are not affected by the water. Means by the water, these 4 elements are not affected. This is the reaction of 14th group elements with the water. Next, we will go for the reaction with halogens. Reaction of 14th group with the halogens. For this one, I will take note. Here it is. Halogens means which group? 17th group. What are the elements? Fluorine, chlorine, bromine, iodine. These are the 17th group elements. These are also indicated with the help of symbol X2. X2 may be F2, Cl2, Br2, I2, etc. X may be fluorine, chlorine, bromine, iodine, etc. Just remember this one. Now we will go for the reaction with halogens. Last reaction of 14th group elements with halogen. Reaction of 14th group. Reaction of 14th group elements. 14th group elements with halogens. This we will discuss. Here also same. The 14th group elements M, that is M means what? Carbon. Here except carbon, silicon, germanium, tin, lead. Right, here I am writing except carbon. Right, except carbon. Other elements silicon, germanium, tin, lead, that is M. Right, reacts with the halogens. Halogens means X2 to form the 2 compounds. Right, here it is MX2 and MX4, means dihalides and tetrahalides. 2 halogen groups are there, therefore it is called dihalides, corresponding dihalides, and 4 halogen atoms are there, therefore it is called tetrahalides. When dihalides are formed, when the element, the silicon, germanium, tin, lead are +2 oxidation state, it will form the dihalides. When they are present in the +4 oxidation state, it will form the tetrahalides. Means how to write this one? When 14th group elements, maybe silicon, germanium, tin, lead, reacts with the dihalogen or halogens. When 14th group elements, maybe silicon, germanium, tin, lead, reacts with the halogens, it can form the dihalides and the tetrahalides. Dihalides and the tetrahalides. Dihalides are found when it is present in the +2 oxidation state, and tetrahalides are found when they are present in the +4 oxidation state. That we have to remember. And here X2 means what? Maybe Cl2, Br2, F2, I2, etc. Halogens. Right. Now we will see the general characteristic properties of these halogen compounds, that is halides. Right. General characteristic properties of halides of 14th group elements. Halides of 14th group elements, that we will discuss now. Now here it is. Now I will take rough paper for this one. This MX4 means tetrahalides. If you see the compounds of these, maybe silicon tetrahalide, germanium tetrahalide, tin tetrahalide, whatever may be, if you see, almost all are covalent in nature. Means almost all compounds of these tetrahalides, 14th group tetrahalides, are covalent in nature, and the central metal atom, that is M, maybe silicon, germanium, tin, lead, it is sp3 hybridized. What is the hybridization of the element, right, a 14th group element, when it is reacted with the halogen and it is forming the tetrahalides, right? Maybe silicon tetrahedral, SiCl4. What is the hybridization of silicon? You have to remember, just it is sp3 hybridized. sp3 hybridized. sp3 means what is the shape? Tetrahedral shape. Tetrahedral geometry or shape. That is only I am writing here. First point, that is, what is the first point is almost these MX4 compounds are covalent in nature, and the central metal atom is sp3 hybridized. I told already, it is sp3 hybridized, and it has tetrahedral shape. Which shape? Tetrahedral shape. Just remember here, MX4 are almost all covalent in nature, sp3 hybridized, and tetrahedral shape. Right. Next we will go for the second characteristic properties of these compounds only. Now for this one I will take another paper. Now just check. Now here, second one. What is this one is? Now for this one I will take rough paper. When lead reacts with the I2, it will form only PbI2. Right, dihalides only. It never form tetrahalide. Correct. PbI4 is not possible. It is not prepared. Right. Only PbI2 is formed. Means when lead is react with the iodine, it will form only dihalide. It never form the tetrahalide. Why, sir? Why it is forming the dihalides only? Now for this one, just remember, if you check the electronic configuration of lead electronic configuration. What is the electronic configuration of lead? Already you know, xenon 4f14 5d10 6s2 and 6p2. Here valence shell electronic configuration is 6s2 6p2. For this one, 6s2 6p2, I will write here 1. S means how many orbital? 1 orbital. P means how many orbitals are there? 3 orbitals. Here it is in this way. Right. Here in the S, how many electrons are there? 2. 1 2. right? P, how many electrons are there? 2. Hund's rule, 1 2, correct? Now here, when this lead Pb, this is for Pb, when it is forming the bond with iodine, when this Pb forming the first bond with iodine, here it is, one iodine is forming bond with this electron, another iodine is also forming bond with this electron, right? While forming these bonds, Pbi bonds, which bonds here? This is Pb, na? This is iodine. When this is forming Pbi bonds, energy is released. When this lead, unpaired electrons are involved in the bonding, that we know, correct? Where the unpaired electrons are available? In the 6p orbitals. 1 unpaired electron, 2 unpaired electrons, means lead can form how many bonds now with iodine? 2 bonds, right? While forming this, lead forming the bond with first iodine, and lead when form this unpaired electron with the iodine, means when this lead forming the bonds with iodine, by utilizing these two unpaired electrons, energy is released. Energy is released. Energy is released, and this energy is very low. Energy is very low. This energy is very low. So that here one of the electron from the s orbital is not jumping to the right here empty orbital, means here electron shifting is not possible, means s electron is not jumping from s to here it is p orbital. This jumping is not possible, means here still these electrons are paired only, s orbitals electrons are paired only, therefore these are not forming the bonds, only these two are forming the bonds with iodine, therefore it can form only Pbi2. Pbi2, just remember here, when Pbi bond is formed, energy is released. This energy is very low, so that s electron is not jumping to the p orbital. Paired s electrons are not jumping into the, right here it is, p orbital. This shifting is not possible because energy emitted is very low. Or the energy released when there is a formation of bond between the lead and iodine. Right? Energy is released. That energy is very low, so that the electron in the s orbital is not jumping to the p orbital. Therefore, only two unpaired electrons are involved in the bonding here. Only two unpaired electrons are involved in the bonding, therefore it can form only Pbi2. This is the second characteristic property. That is only I am writing here. Here I will write what is this one is. Lead is available in Pbi2 form, not in Pbi4. Because here I will write because while formation of Pbi bond, it releases the energy. And that energy is not enough, correct? Not enough to jump the electron from where to where? 6s orbital to higher energy orbital. Therefore, this lead is available in Pbi2 form, not in Pbi4, because energy released is not enough for jumping from 6s to the higher energy orbitals, right? This is the second point. And the third point is very simple one. What is that one is? Thermal and chemical stability of lead and germanium as shown below. What is this one is? Just check here. Germanium, when it is present in the Tetra Halide form, correct? There is germanium Tetra Halide is more stable as well as thermally and chemically. Means germanium tetrahalide compounds are more stable than the germanium dihalide compounds. Means when germanium is present in the +4 oxidation state, it is more stable thermally and chemically than the germanium when it is present in the +2 oxidation state. Now what about lead, sir? Lead Pb, right? When it is present in the tetrahalide form, it is less stable. It is less stable when it is present in the dihalide state. Means dihalide state of lead, means +2 oxidation state of the lead is more stable than the +4 oxidation state of the lead, whereas for germanium, +4 oxidation state of the germanium is more stable than the +2 oxidation state of the germanium. Means germanium more stable in +4 oxidation state, lead is more stable in +2 oxidation state. This is the meaning, right? Now we will go for the last point, right? Last general characteristic property of the 14th group elements, last one, that is here tetrahalides. When the tetrahalides, for example SiCl4, when it is reacted with the water, 4 moles of water, means 4 OH and 4 hydrogen are there, 8 hydrogen, right? Here just check here, simple, 4 H2O means total how many hydrogens are there? 8, right? How many oxygens are there? 4. I can write 4 OH minus 4 hydrogen, 4 oxygen I have removed. Means how many hydrogens are left? 4. 4 hydrogens, H plus are left. Means here 4 H2O means 4 OH minus 4 H plus, right? Now here 4 hydrogens reacts with the 4Cl. 4 hydrogen reacts with the 4Cl. It will form 4HCl. 4HCl. And this 4 OH reacts with the silicon and it will form silicon tetrahydroxide. Silicon tetrahydroxide. Means when the tetrahalides of 14th group, tetrahalides here, 14th group means silicon, correct? Halide means Cl. When the tetrahalide 4Cl is there, when the tetrahalides of 14th group elements are easily hydrolyzed with water, to form the corresponding hydroxide, that is shown in the reaction. That is only I will write here. What is the point is the tetrahalides of 14th group elements. The tetrahalides of 14th group elements are easily hydrolyzed. That is in bracket, break down by water. That is, this reaction is the example. Particularly if you want to see the structure, now just check here. I will write here silicon, 1Cl, 2Cl, 3Cl, 4Cl, correct? 4Cl atoms are there. When react with the 4 OH minus, the Cls are replaced by the OH, that is SiOH, OH, right? In this way the reaction will take place. Now we will stop here only and we will continue in the next video or next class.